Hello everyone and welcome back to another video on African Tech Gurus. Today we're going to do the tasks for the pointers project, and the very first question that they have for us is the 98-bit tree ST, and what they want us to do is write a function that takes a pointer to an integer as parameter, and then it updates the value that it points to 98. And we've been given the prototype and all that we need. So I've already created the specific directory that they want us to create, which is 005, and I've already created the first readme, which is always compulsory. So as you can see where I'm at, I've already created the directory. This is the directory, and inside it I've listed all the files. I already have my readme file, and within that readme file, it's not empty. This is what it contains. If you see, I've used cat readme.md to see what is inside. It's not empty. I've just simply put the name of today's project. And now let's start with the very first question. So one thing I always do is I always copy all the prototypes at once and then have them somewhere such that it's also easier for me to do that. So let me open that file that I have my prototypes in. So this is the file that has all my prototypes. If we go back to the instructions, they always tell us where the prototypes should be. So here they're saying all the prototypes should be in a file called main.h. And I've done that. So let me just copy the name of the file. We create the file name very quickly, vi, and the name of the file, paste it there. And then now we can copy all the prototypes. So I usually like doing that in advance such that it's easier and I save a lot of time even when I'm doing my own tasks as well. So I'm just going to paste it here, and they are all the prototypes that we need for today, and then just save that. So now when we list all the files, we have the readme file and we also have the main.h file which contains all the prototypes. So the very first question that they're asking us is they want us to write a function that will take a pointer to an integer as a parameter and then update the value that it points to 98. So we need to create this file first, the one that will actually have the main function and where the program will start. And we copy what is contained here so that we're able to run GCC at the end of all this. I paste it there, and that is okay. And now I want to put the solution that will have the function that will take a pointer to an integer and then update it to 98. So that needs to be in a file called 0reset to 98. So let me also do that as well. And now I also have my solution, and I'll explain the solution as well. So here we have the user-defined library, and we have the comments and what it's the function is going to do. The function is going to take a pointer to an integer and then update it to 98. And then n is the value that you want to update it to 98. And here we are just using the reset function which they've given us, and it's a prototype. And all we are doing is we're saying where the pointer n is pointing to, just have it as 98. So the address that is being pointed to here, whatever value is contained there right now, we just want it to have 98. So previously, as we have seen, it contained 402. Let me go back so that we're able to see that it contained 402. It contained 402, and this is it. So it contained 402. So now we want it to contain 98. So that is that. So let me paste my answer over here, and then we can run GCC. Now we can run GCC, and hopefully it will give us the answer that we are looking for. So I've copied the GCC command and all the options, and while it runs, I want to check if there is anything else that we were supposed to do. There's nothing, so now we can actually run and execute the executable file that we were given, and it will give us the two values that we see there. So it will give us n is equals to 402 and n is equals to 98. So that has been updated correctly. So as you can see, now we are good to go and our solution is okay. So now we can clear what we have and then we can move to the next question. And the next question is, they're telling us that write a function that will swap the values of two integers. And so we'll have two integers a and b, and they'll contain 98 and 42 as you can see here. And what they want us to do is they want us to swap the values that are in these two integers, and you're supposed to use pointers because that is what we have learned today. So the first thing I want to do is create the file one main.c so that you're able to run our GCC command. So let me copy this. You can also do this as well, feel free. And that is copying. Let me copy here. I've copied it there. So now they want us to use the prototype. This is the prototype, and write a function that will swap these two values. So already they've given us the prototype of the function. They just want us to put in the body of the function. So it is as simple as that. And I already have my solution over here, and that is my solution. So what this does, let me explain it before we actually type it out, is it will take in two integers. So what I'm saying will take in two integers is the prototype function. The swap int is a C function, and it will take in two integers pointers, which are a and b, and then it will swap the values that they point to. So it does this by temporarily creating a variable called change. This is supposed to be change, called change, and what change will do, it will store the value that is being pointed by b, this. So whatever b is pointing to, that will be stored in change, and then it will set the value that is being pointed to b to be the value that is being pointed to a, that is happening here. And then lastly, it will now set the value that is being pointed to a to be the value that is saved and stored in change. So at the end of the day, what will happen is whatever value was stored in a will now be stored in b, and whatever was stored in b will now be stored in a. Remember, there is no return in this function, so the function will not return anything because it is void, but it modifies the values that are just stored in memory at the addresses pointed to by a and b, and this is address b and this is address a because of the asterisk that is present to indicate that this is a pointer. So this function definitely will use the main.h library, which is what we created in the beginning of this video. So make sure you have that, otherwise it will not run correctly. So let us have this in a file called one swap. So let's create that file over here, and then we can finally paste the code solution, and this is the code solution. I have it there, and then I paste it, and then now we can save it, and now we can run it. So what you're supposed to run, the GCC option, this is the GCC option that we have over here, and it will give us an executable file called one-swap. Yes, one-swap. And that one-swap is the file that we are supposed now to run for it to give us and show us that the two values have been interchanged. Yes. So as you can see, initially A had 98 and B had 42, but then now, once we have swapped the two values, A now has 42 and B has 98. So we now move on to the next one, and it is telling us that we're supposed to write a function that will return the length of a particular string. So they've already given us the string that they want us to look at, and this is the string, my first strlen and exclamation mark, and they want us to find the length of that string. So we need to create this file, which is to-main, which will contain the string that we should get the length of. So I'm copying that code that they have given us as it is, so that I don't make any errors. And once I have it, here, now we can actually now look at the solution that I have. So the solution that I have, let me open the solution for us to quickly look at it and understand what it is doing. So what is happening here, as usual, we are using the main.h library, which we had initially. And what is happening is we have the function called underscore strlen, and it will take in a pointer, and the pointer is s, and it points to a character, an array of characters, sorry. So at the end of the day, it will return an integer which is supposed to represent the number of items or the length of that specific string. So the function, what it does is it will calculate the length of the string. It will calculate the length of the string, and the first thing that it does is it initializes a variable, and this is a variable string length, and it starts counting at 0. So as long as the string length is present, then it will increment it each time it encounters a character that is not null. Because as you know, when it encounters the null character, it knows that is the end of the line. So as long as it has not encountered that null character, it will continue counting. And how it does this is using the while loop, and this is our while loop here. This is our while loop, and it will continue counting until it reaches that null character. And I hope you remember the null character is the / and the 0, which is usually present at the end of a string or a sentence or a word. A string is definitely a word. And then definitely at the end, we have the return. And what it does is the function returns the string length. And that is what we want. We want it to return how many characters, or what is the length of this specific string that we are counting. And then remember, this function does not modify the string that is there presently. It will not modify it. The only thing that it will do is it will count the number of characters that are present. So it will not modify the string by any way or form. So now we can put our solution in, paste it there, and then our solution, this is our entire solution. If you have any questions, please feel free to ask down below, and we will try as much as we can to help, because we really want to understand the concept and what is happening. So now, once we have that, we can run our GCC. Let's try and run our GCC. That is that. And then I copy it there, and then I paste it. And it has run. So now we can run and the executable file that it has provided for us to make sure that it has given us 16, which is the length that we have for that specific character that you have, this over here. So I hope you've understood that up to there. So now we can move to the next question, which is number 3, which is I do not fear computers, I fear the lack of them. And here we're supposed to write a function that prints a string, and it should be followed by a new line, and it is printing this out to the standard output. So here they're already giving us a file 3-main, and it contains the character string. It contains a pointer str that points to an array of characters, and this is the string that we have, and this is exactly what it is saying. So we can copy this and create this file before we look or move to the next thing, which is the solution. So let me paste this here, and this is the code that they have provided for us, and I paste it there. And now we can move to looking at the specific solution for this one. So let me open that file real quick, and this is the solution that we have. So what is happening in this specific solution? We have a function that is called _puts, and it will take in a pointer. It takes in a pointer that points to an array of characters as well, or in other words, a string, and then it prints it prints to the standard output, sorry, which you can also call it to be the console. Yes, which is where whatever is being displayed by the computer, you're able to see it. And then we initialize an integer I to 0, and what happens after this is we use a while loop, and we use it to call another function, which is putchar, that prints a single character to the standard output, one by one by one. I hope you remember the putchar function. It's a function that they have provided for us, and what this while loop does is it continues printing out a character at a time until it reaches the null character. Remember the null character, which always marks the end of a string or a sentence. That is what the compiler or the computer will know, that the string or the sentence is ending at this point. And then after printing this entire string, it will now print a new line. This is it. So it will print a new line at the end of it all. So this function, like the other one, it does not modify the original string that was provided. It just takes one character at a time and prints it into the console for us to be able to see it. So this happens very fast, so you won't be able to see it happen slowly by slowly, but it does this very, very fast. So now we can copy our solution and try and run it and see if it will be able to run. So that is the name of the file, and this is the solution. I hope you've been able to understand my explanation, and I hope you're able to now understand how to carry out your solution. This is not the only way. There are very many ways of doing this. I'm just choosing the simplest and the easiest for us to be able to understand. Now I want to copy the GCC command so that we're able to run it and we're able to see whatever is going to happen. I don't have the underscore putchar.c file, so let me get that right now. So let's look for our putchar function. So this is the putchar name of the file that we need to create, and we're just going to copy it and paste it because it has some functionalities that are required for this task, and this is the body of the putchar function. So I'm just going to paste it here so that you're able to use it. Sorry, I'll paste it there, and there it is. And now we can move to the next thing. So now I believe we can now run the GCC. Hopefully it will run correctly now, which is good. Now it has run. So if you're using your local PC, you need to have putchar in as one of your files. But if you're using the terminal, you're covered because they will provide their own putchar function. So now let's continue. Let me clear this so that we're able now to move to the next step, and that is executing the executable file that has been produced at the last step when you run GCC. So it gives us "I do not fear computers, I fear the lack of them" by Isaac Asimov, which is the output that we should get. So now we are free to move to the next step. And the next step or the next question is the fourth one, the one that we're looking at, and it says I can only go one way. I've not got a reverse gear. So what you're supposed to do in this specific question is write a function that will print a string in reverse order, and then once it does that, it should print a new line. So the first thing we need to do is create this for.c file, for-main file, sorry, that contains the main function, which is part and parcel of today's work. So I'm going to copy it as it is. It contains the string that we are supposed now to print in reverse, and it's the same string that we have seen in the previous question. So let's paste it, and then once we paste it, we can save it, and then now we can move to the solution for this specific task, and it should be in a file called for_print_rev. So let me just create that file before we actually look at the solution that we have. So Let's move now to that question. This is a question, so let's look at what is happening in this specific solution. So as usual, we're going to use the main.h library that we have, and then we're going to use the print rev function, and this is a function that this is what it's going to do. It's a function that will print a specific string that we have provided to it in reverse order. So the first thing that it does is initialize declaring of an integer called start and initializing it to 0. And then the next thing that it does is this function now will use a while loop to calculate the length of the string that we have. So that is being done here. So start is initialized at 0, and it will count the number of characters that are in this specific string that has been provided until it reaches the end of the string, and it will know that it has reached the end of the string when it encounters a null character or a null byte. And then once it does that, what it does next is it now uses the start. Now at the end of counting to the length, it will have the specific length of that character. So if it is 100, then it will start counting from 100, and that is stated here. So it will start counting from 100 and decrement until it reaches 0, where there are no more characters left. So as it is decrementing from the length, the entire length of the entire string, it will print or put one character at a time. And what this will do is it will print the 100th character and then the 99th character. Once the 99th character has been printed, it moves now, decrements, and then moves to the 98th character, prints it. Once the 98th character has been printed, decrements, and then prints the 97th, all the way until it reaches the last character. So that is equivalent to it reaching to start is equivalent to 0. So at that point, the loop will stop and it will print a new character. So we are using a while loop which will continue printing out a character or putting out the characters of the string until it reaches start is 0. So it's as simple as that, and just like the other ones, it will not modify the original string at all. So now we can copy our solution that we have and put it in and run our GCC command. So let's put it there, and then now we can see what is happening. So now we can run our GCC, and this is the GCC, and it's going to give us a executable file that we can eventually run. So the executable file is for print_ref, and once we do that, it is supposed to get the string, but now in reverse order, and it should look like so. That has been successful. So now we can move to the next question, which is this one that's saying a good engineer thinks in reverse and asks himself about the stylistic consequences of the components and systems he processes. So here we're supposed to write a function that reverses a string. So whatever string that they have provided or whatever string our program encounters, it should print it in reverse. So the first thing we do is create this file. We create this file called vmain.c, and it should contain this specific body. It contains the main function, which contains the body of what we should print in reverse. So let me paste it here, and then now we can move to the next step, which is the solution, and look at what the solution is suggesting and one of the ways in which you can do this specific question. Sorry for that, I wanted to paste. So let's create that file named 5revstring, and then now we can now look at our solution and explain what is happening. Give me a minute, let me reduce the size. So this is the solution. So we're using the main.h file and we're using the function rev underscore string, which what we'll do is it will take in a pointer, which is a pointer to an array of a character arrays, which is the same thing as a string. And the specific one is s, and it reverses the order of the characters in this specific string. So it will first calculate the length of the string by using a for loop. So here we're using a for loop, and what this will do is it will calculate the length of the string, and as long as it has not encountered the null byte, it will count the characters that are in that specific string, and it will keep on incrementing it. This is the update statement, that it will keep on updating it until it reaches the null character, which is base, which is usually at the end of the string. The next thing that it does is we initialize two more variables. Here we have z and we have half. So z is set to 0, as you can see here, and half is also set to half the length that we have found for this specific string. So what is happening here, which is not the next step, the function now is using a while loop, which will decrement half of that statement, and it will reverse the order of the characters in that string. And then inside now the loop, what is happening here is it is swapping the characters at the current index z with the characters that are now corresponding to the index on the other side of the string. And this is done using the length minus z minus 1, which is this one over here. Okay, and then this is done using a temporary variable, which is what we're using, or we're calling temp, and it will hold the value of one of the characters, which is now going to be used during the swap. And then finally, the function will not print anything, and it simply modify, and it will simply not modify the original string s, which will now be in the reverse order. So I hope you got that one, because now what is happening here is it is just taking the half and then working backwards and printing the specific characters one by one. So I hope you got that one. If it's not clear, just let us know and we will go through it again. So this is the solution that we have. Let's copy that and then we paste it here. We have that, and then now hopefully we can now run our GCC, which is this. We can run our GCC. And it will give us a file called 5revstring, which is now supposed to give us half of the values that we had in reverse order. So yes, we have that. There it is. The original is my school, and when we reverse it, it's as it is over here. So now we can clear and we can move to the next step. So the next question is, half the lies they tell me aren't true. So here we're supposed to write a function that prints every other character of a string, starting with the very first character and then followed by a new line. So we have the file 6main, which is the file that we're going to use in this one. So let us create it on this side, and it should contain this specific block of code that is here. And the file that should contain our solution is called 6puts2. So this is the name of the file. There it is, that is the name of the file. And we're just going to paste it there. And now we can look at the solution and understand what is happening in the solution. So this is it. This is the body and the solution, but we're going to go through it now. So before we actually look at this, I want us to look at how our solution, or how the output that our program should give us. It should give us this. So as you can see, it's giving us 0, 2, 4, 6, and 8. And from the string that we have 0 all the way to 9. So as you can see, it's only printing out the values that are divisible by 2. So now we can look at our solution. So what is happening here, we are using put2 function, and what this function is doing is it's taking a pointer to a character array or a string, and it will print out every other character of that string starting with the very first character. But remember that our output should only print the characters that are divisible by 2. So that is the code that, or the solution that we should write. So here we'll use a while loop. This is a while loop, and before that we are initializing and declaring a variable z to 0. So we're using a while loop to go through or iterate through the characters of the strings, and the characters in the strings are 0, 1, 2, 3 all the way to 9. And then inside now this while loop, we are putting a control statement where we're saying if for the entire length of the string, make sure that we end this condition or we end this loop when we meet the null byte or the null character, which is usually at the end of the string. And we're using an if statement to check that the character that we have encountered is divisible by 2, and once we divide it by 2, it gives us a remainder of 0. And once we get a character that is divisible by 2 and gives us a remainder of 0, then we can print out that specific character, which in this case it will be 0, 2, 4, 6, and 8. And then once we have found that, we move to the next character, and this is what it does. It just increments the count so that we move to the next character, and it does this until we meet the null byte. And once we've done that, we are now able to print a new line. So it's as simple as that. There's nothing complicated to it. So now I believe we can copy this and see if it actually gives us the same output as the one that is in the question. So now we can run our GCC command, which is provided here. This is our GCC command. We paste it there, and then we run it, and we are now able to execute our executable file that we have on this end. And yes, it's given us 0, 2, 4, 6, and 8. So now we can move to the next question, and it is winning is only half of it. So what is happening here, we're supposed to write a function that will print half of a string, and then once it does that, it's supposed to be followed by a new line. So the file that you're supposed to use is this 7main. So let's create that first. So let me paste it there, and then now we can copy the body of this program or this file, and you place it here. Now we can save that, and then now we can actually now look at our code. And as you've noticed, this is the string that we have, the same 0 all the way to 9 is supposed to only print half of it, and half of it will start from 5 all the way to 9. So let's now look at our solution. So this is it, and what is happening here? So we have a function called puts_half, and it will take in a pointer to a character array, and it will print only half of it. That is what it's supposed to do, and then followed by a new line. So the first thing that is happening is we're using a while loop to go through the characters of the string to find the length of the string. So that is what we are doing first, and this is it. We are just going through the entire string to get to know what is its length. So that is what we are doing. And then the next thing that is happening is we want to get to know where is the middle of this string. So that is happening at this specific point. We're getting to divide just the entire length of the full string by 2 so that we get to know the midpoint. And then once we've gotten to know the midpoint, we check if the length of the string is odd, then the middle character will be included in the second half. If not, then it will be very straightforward. So the next thing that happens is now the function will use another while loop here, and what will happen here is it will iterate through all the characters again, starting from the half string, which is this. It will start from the half string, and it will start from the half string, and that is where it will start actually printing from, and it's just going to check that as long as half the string is not greater than the entire length of the full string, because it definitely can't be greater than that. And once it checks that, it now starts printing, and it will start printing from the half of the string, so from the middle of the string, and that is here. So it will put the characters one by one and continue incrementing until it gets to the end, and then once it gets to the end, it prints a new line at the end. So this is a very simple solution to this task. So let us print it and see if it will actually give us the same output as the one that is in the task for us to do today. So this is our solution. We put it in here, and after that we will now run our GCC command, which has been provided over here. So this is the GCC, and it will give us 5, 6, 7, and 8 once we run the executable file that we get from running our GCC. So let's say it will give us 5, 6, 7, and 8, and indeed it has given us 5, 6, 7, and 8. The next question that we have is arrays are not pointers. So what is supposed to happen here is we're supposed to write a function that prints n elements of an array of integers, and then once it does that, we print a new line at the end of it. The file that we're using is 8main.c. So let us create that over here, main.c, and this is the block of code that should be contained in 8main.c. And once we have that, we can go ahead to the next step and create the file that will contain the solution, which is 8printarray. So this is vi, and then the name of the file, it is, and then now we can look at the solution and explain it further. So this is our solution, and it takes a function called printarray, and it will take in a pointer to an array of integers, which is called a, and an integer n, which is now going to represent the number of elements that are supposed to be printed out, and that is seen here. These are the arguments that are taken into the function print array. So the first thing that is happening is we are initializing, we are declaring an integer which is going to contain the index of the array, or the number of elements that are in the array. So we are using a for loop to go through all the elements, and this is the for loop. It's going through all the elements in the array from index 0. So it's going to start at index 0, and that is seen here. It is going to start at index 0 to the index just before the last element, and that is the null byte. The very last element is the null byte, so that should not be counted in this case. And now what is going to happen is it will print each element using the printf function. This here, it will print each element using the printf function, and here we're using the format specifier for decimal integers, which is here. So this is going to be a placeholder for the values that are in the array, and it will print one by one. And then after printing each element, what happens next? This specific function is now going to check if the current element is not the last element. And how it's going to do this, it's going to compare and check if the index is not equal to n minus 1, where n is the number of elements and minus 1 is the second last element. I hope you got that one. So what does this mean? It means that it is not the last element, and if it checks that this is not the last element, the next thing that it will do is it will print a comma. So that means it's going to continue. So once it prints a comma, it continues to print the next element in the array. So it will only stop doing this if it encounters the last element where this condition is not met. And once the for loop completes, it prints out a new line, and that marks the end of this specific program. So it's as simple as that. So now let's put this here. And now we can run our GCC and hope that it runs successfully. So we put our GCC and it will give us an executable file called 8printarray, and let's run it and see if it will give us the same solution as there. So 98 for 2, those are the elements or the items that are in the array, and it's the same ones that we have actually received on this end. So now we can clear this and move to the next task. The next one is we're supposed to write a function that copies the string pointed by src, and it should include the terminal null byte to the buffer pointed by dest. So we have this file, which is the file that we're supposed to be working with. So let us create that on this end. And this is the body that should be contained in that specific file. Sorry, this is the body that should be contained. Paste. Yes, now that I've pasted it, now we can create the file that should contain the solution, and we paste it there. And before we look at the solution, let us open it and explain what is happening. So here we have the main.h library as usual, and we have the prototype, which is this, and what is happening here is this function is taking in 2 arguments, and these are the 2 arguments. And what are these 2 arguments? One is a pointer to the destination string, this one, dest, and the other is a pointer to the source string src. So those are the 2 arguments that this specific pointer function is taking. And then the next thing that is happening is it's supposed to copy the string which is being pointed to by src to the buffer pointed to by dest. So how is it going to do this? It's going to use the do while. This is the do while loop. So this do while loop will iterate through the source string. It will iterate through the source string and until it reaches the null character. This is the while loop. So until it reaches the null character, it will copy each and every single character to the corresponding position in the destination string. And then once it does that, it's going to return a pointer that will point to the destination string, which is called dest. So remember about the null terminating byte, which is this. So what is happening on this end is we are initializing z to -1 such that we don't have the null byte for the src because the dest will have its own. So that is how we are going to do this specific task and solve it. So we are going to put this here and save it, and then we can now look at the GCC and run it so that it gives us an executable file that we can check and see whether our solution is correct, and it gives us the very same output as this other task that they are giving us. So that is that. The 2 files that we have, or the 2 variables that you have, or the 2 memory locations that you have the very same content. So this is it. Here we both have first solve the problem and then write the code. That marks the end of the mandatory tasks. Thank you for watching today's video. If you've liked it, please give it a thumbs up. Please subscribe if you've not, and let's continue learning. And until next time, happy coding.